Hello, welcome to this video where we're going to look at how we can analyse the sort of output you get from a questionnaire survey that you've carried out online. This might be through Google Forms or Microsoft Forms or the JISC one that our ARU Writtle students might use, or anything that gives you what looks like an enormous and fairly complicated spreadsheet in the first instance. But Jamovi as a software package makes short work of that. I'm very grateful to Dr Sue Judd, who used to be a colleague of mine at Writtle College back in the day. And Sue was looking at how farmers were struggling with their businesses, and they were looking to diversify into other practices, particularly those relating to horses. So she carried out a really nice survey of volunteer riders to see what they wanted. And she was saying, would you like more access to the countryside? Would you like more access to equine events? Would you like a cross-country course? What about an indoor school? All of these things are things that could be part of a farm diversification program. Additionally, she asked for a whole lot of demographic information from these people. How old are you? What is your occupation? Where do you live? Where did you pick up this survey? It was paper-based back in that day. Anyway, I'm going to show you the data now, and it's quite alarming, but don't worry. Here, this is the sort of thing you get from those electronic databases when you download the SurveyMonkey or the Google Forms data. It looks like this. Oh my goodness. Lots and lots of columns, lots and lots of rows. Look at them. All the way down, all the way down, all the way down. Yeah, over 500 rows of information here. Let's look at these in simplicity. The first column is simply a case ID number. That's quite useful for reference. Now each row underneath the headings is one person answering one questionnaire. And each column is one question, or one part of per question. And that's the data set. Actually, I've cut down some of it for this purpose. But here you can see we've got where did you find the questionnaire? What's your gender? Are you in full-time or part-time work or education? What is your job? And that's all coded. What was your income? What's your age category? Where's your home address? Lots and lots and lots of information. Here, and here's the main, so that's all sort of demographics, and here is our main questions. Would you, what's the main concern for you at this current time? Is it the unavailability of the countryside? I've shortened that to unkside. Here. 1 means yes. That is a concern. I would like access to the countryside. 0 means no, which presumably means they've already got access to the countryside or they don't need it. Here, this person isn't worried about a lack of events, but this person would like events. This person is not worried about access to a cross-country course. This person would value it, etc., etc. Okay. So here's the data. We need to make sense of that. We need to do an analysis, and this is where the chi-square contingency table is a very powerful tool for this, and Jamovi is a very useful piece of software. But we need to get it from Excel, where we are at the moment, into Jamovi. Now I could just press Ctrl A and copy all the data across, but I'd have to do all sorts of shenanigans to sort out my column headings if I did so. I could take off the top row and just do everything else and just copy it without the row headings, but then I'd have to put the row headings in afterwards, and there's an awful lot there. The best choice, and probably the most sensible choice for any professional statistician, is to export this as a CSV, a comma separated value file. We do this in Excel through the export. So we go to the File menu, then we go down to Export over here on the left, and then we've got these choices. We want to change the file type here, and this is where we've got various Excel ones, but this is where we find the CSV, the comma delimitated file. I'm going to click that, and then so I've chosen that one, and then I'm going to save as here. So I can call it what I like. I've already got it up here. So I've got this one as the name of the file, and then I've added the word questionnaire. So that makes sense to me in my overcomplicated file names. And it's a CSV file. And when I press save, it's going to give me a little warning saying, hey, you've got this one already. Yes, I do want to replace it. And it gives me another warning here that says, the CSV file type, the selected file type, does not support workbooks with multiple sheets. Look, there's all the other activities in this exercise. If you only want to save the active sheet, and that's the one we're looking at, then click OK. That is indeed what we want to do. So here, we're going to press OK, and that saved it as a file. Right, I'm just going to take a quick pause, and then we'll go over to Jamovi and bring it in. Here we are in Jamovi, and we need to get the data. Okay, so we go up to the hamburger, these 3 lines at the top, and we're just going to open that CSV file we created. So open, and here you can browse to the file. Here I have it in my recent file, so I don't have to go through all those little different file folders and everything. So I'm just going to click there, and it's going to bring in all of those data. Look, there they all are, and it's already put all the different codes in there. There's a few that are just marked as text. I'm not going to use those in my analysis. Everything else is marked as a nominal data variable, and that's just fine for me. Okay, right then, very straightforward. We're just going to look at, in the first instance, we're going to look at what are the associations between age category and that unavailability of the countryside. Do people of different ages have a different opinion on whether countryside availability is a problem to them? So in Jamovi we have these different blocks, and it's in frequencies obviously, so we're going to look at frequencies here, and we've got our choices, and this is a contingency table. We're looking at 2 categories, so 2 independent samples. We're looking at a test of association here, so we're going to click this one. Now I've got multiple options here, but because of the sort of rows and columns nature of this, where you've got the questionnaire survey data, I don't have a separate count column. It's going to do the counting for me, which is really helpful. So I'm going to put the age in the rows to match the data set we've been looking at. There's all my age categories. And straight away I can see a problem. It's done this in alphabetical order, and under 9s are at the bottom, when obviously under 9s need to be before the 10 to 14 age category. Okay. Well, before we go any further with this, let's go and fix that. So I'm going to go back to my data, and I'm going to find my age column. Where has it gone? There it is, age column. I double click this one, and here are my levels, and you can see that under 9 is at the bottom. Well, if I click under 9, I can just move it up the list, up the list, up the list, up the list. Keep going, up the list, up the list, up the list, all the way to the top. And there it is at the top. That's good. So I just click outside that and make that go away. And you can now, and it's very pleasing, see that under 9 has come to the top of the list. And that can be really helpful if you need a particular order that you're trying to get to display your data, or in a survey where you want the categories to fall in that particular order. Alright, let's get on with the analysis. So I'm back to my data. I don't want to go through all the process. If I just click this table, it all comes back to where I wanted it, so that's nice. Here, so age, and I was going to compare that with that question about the countryside. Well, that's here. Unavailability of the countryside is my column variable, and it's populated it already. Very pleasing. And here the chi-square test has already been run. The chi-square value was 9.68. There were 9 degrees of freedom, and that equates to a probability of 0.377. So I don't reject my null hypothesis. There's no significant association here. But there's the reporting of it. Now I have a bit of a trick here to help with the demonstration. I'm going to right click this table and I'm going to copy this table, and I'm going to go back to Excel where you'll see that I've prepared a template ready. Most of these data will fit it nicely. So let's go back to Excel, and here is my template. Now I've set this up, I've copied this in actually from a Word document, so it's all ready to go in a thesis. And I've got all my age categories already there, and I've changed the UNC side 10 or 01 to a full is unavailability of the countryside a problem to you? No, and as a percentage, yes as a percentage. And there's my total here, and there's a space for my p-value as well. So if I just scroll down a bit, I'm just going to right click and I'm going to paste in what I just have. Okay, so this is really good. This is the one problem I found in Excel, is Excel, if I do 10 to 14 in Excel, it automatically makes it October the 14th, October being the 10th month. That's really annoying. And so if I go up to here and turn that off, choose the number format, I don't want it to be a date, I want it to be a general format or a number format, it goes to 41,913 from some bizarre Julian calendar thing. So that doesn't work at all. The fix to that one is the apostrophe. If I use an apostrophe, it forces this to be text. If I put in 10 to 14 here, press enter, you don't see the apostrophe, but it's there. And that will copy across to Word later on, and that's what I've done here as well, to fix that silly error. Anyway, what I've got here are my original counts, but I do have the totals. So I'm going to take these totals to the right part. So here I've got the under 9 data down to no answer. Under 9s is here, it's in the second row. So I'm going to put that here. So if I paste special, it shouldn't copy over these lines. So here, right click, paste special. I don't know why the 3's gone over there. We'll sort that later on. Let's put those in the middle, like that, and they should all be font 9 to match everything else. Are they font 9? No, font 10. Let's go up one. Boom. There we go. So that's that part of the data. So those numbers here have become part of the data set. But I still need to fill in these numbers, which are the percentages and the p-value. There's just one p-value for all of this. Where do I get those from? Well, we need to go back to Jamovi. Okay, off we go, back to Jamovi. And here is the original contingency table. What we had here was the observed counts. If we were really interested, we could do the expected values as well alongside them. That makes for quite a complicated table, so we won't do that. What we do want are the percentages. We want the percentages by row. We want to look at the individual age group. Let's pick 20 to 24 and see what percentage of the 56 total said no, they weren't concerned about the lack of availability of the countryside, or the 18 out of the 56 that were concerned about the unavailability of the countryside. To do that, we can take the tick out of the observed counts, but we can put it back in the rows here. Now we've lost our totals there, but we've got those already. But now we have these percentages, and that's what's going to be useful for in our main descriptive data presentation. So all I've done is just take the tick out of this box, put the tick in this box. The chi-square is not changed, there's the same p-value. We're just going to right click this new table and go back to Excel, and we'll just paste this one alongside the last one. We're just going to paste it there. Now, because the rows are a bit big, it's double it up. It looks a bit messy. So I'm going to take these values. Again, from under 9s, we can ignore the 10 to 14s. I'm going to take these values, apart from the total at the bottom. We don't want that. I'm going to copy those, and I'm going to paste them here. Now you have to be a little careful in Excel, because these values, if you look here, 94%, it's actually stored as a percentage. If you start playing with that, it can get a bit messy. I'll show you that in a moment. So here, if I right click there, if I paste them in as straight away as percentages, that's okay. But if I paste them in as values, they all become decimal values. That's okay, but we wanted the percentages. So I'm going to paste them in as percentages. Notice that I've lost my line at the bottom. We can put that back. We can take that and we go to the borders and shading. I'm going to put a thick bottom border in there, and that's my line back again. Okay, that's good. Let's make these the right size as well. The Jamovi copied them in font 9. I want them in font 10. Let's make everything font 10 in the table. Let's make everything centered in the table, and we're ready to go. Okay. So we've got all the parts to our table here, but what I can't do is at this stage is remove these percentages. If I click in 94, if I delete that percentage, it goes to 99,400, and it's still a percentage. So let's not do that. I'll undo that. Yeah. If I went to here and changed it to a general number, it changes to 0.94 like before. So we'll leave it like this, and when we copy this over into Word, it no longer has that percentage Excel spreadsheet type function, so it will be easier to deal with over there. So what we've done is we've taken these numbers apart from the total and we've put them into our table. So we've taken the first contingency table, which was just the actual counts. The second version of it was the actual percentages, and all we're missing now is one more number, and that is the p-value. And where can we find that? Well, if we go back to Jamovi again, it's here. So we right click this one, we'll copy this table, and we'll put that at the end, just here. Paste it there. They don't need to be that big. Let's make them a bit smaller. And they're all on the one screen together. So here, just to keep it consistent, that's our p-value there. So I just need to write that in alongside age, because that's the category that all of these different levels fall into. So here I write in 0.377. Okay. So what I can do now is I just take everything and I'll copy that, and I can copy that into my thesis, and there it is already. I've got percentages up here, so I don't need percentages there. That make the table a bit more messy. So if I just select those values and I can press Control H, find and replace, I'm going to find the percentage and I'm going to replace it with nothing, replace them all. I don't want to search the rest of the document because there's other percentages I want to stay. So I press no, close, and there is my table ready for my thesis. Now the only thing to add is that here we've looked at age versus the unavailability of the countryside, but we could have added another demographic as well. So we could repeat that analysis, and here we could just, and the table layout, we want to insert some rows below, some more rows below over here, and here we might put job status or something like that. And that could, I'm making this up now, but it could have been a full-time, it could have been, well, let's write in full-time, it could have been part-time, it could have been education. And this is my next demographic question. Make it bold, make it italic to make it stand out, and then I could add these values. Remember, this is a yes/no question here, so I can just do the proportion of yes/no here, and that would have its own p-value, and I could build a table with lots of demographic questions against my single most important aptitude question that links to my main research question. Okay, that is how to present our chi-squared data with a full descriptive analysis, with our percentages, with our totals, so we know what the percentages are out of. That's always important. And there's the p-value. That's the one that makes everyone mad. I like that, but if we take that out, you can see that the table is much cleaner, can't you? Ready to go. Ready for your thesis. Thank you for watching.